Taipei 101 Overturning Moment. So the first thing I want to talk about is the idea that a building might overturn, that it might fall over. It's what we call instability. The basic physics behind all this boils down to Newton's law, that for every action there's an equal and an opposite reaction. So when wind blows on a building, we have a force acting on the building at some distance away from the bottom of the building, from the base. So this force times this distance has to be equaled someplace else in the building. So what we have to do is introduce another force acting perpendicular to the force against the building. So as I push on the building this way, the building continues to move, it starts overturning, you can see a gap appearing at the base. In the other direction, however, I've applied some chains that resist the tension forces. When I push them this way, you actually see the structure start to deform. It's resisting the overturning. This force is being equated to a force in this chain. In fact, in addition to the force in the chain, when we push in this direction, there's also an unseen force pushing back. As this block pushes against the base is also pushing back against it. Action, reaction. So it's important when we design buildings that we have these forces balanced. You'll notice in this model that I've taped two side blocks to the main structural core. Unfortunately, in building my scenario, there's no way I could have made this slender piece stable. No matter what I tried, you wouldn't be able to see the interaction of the forces, because that interaction would be acting over such a small area. And in fact, when we think about balancing the force times this distance, it's the same thing happening here. Force is occurring here, and a compression force is occurring here, acting at some distance separated from one another. So the broader we can make that base, the less force needs to be in tension or in compression. Now, in this first example, I use these chains to simulate tension. But in reality, when you're building a tall building, it's very expensive to go down and put in some type of device that resists tension like that. It essentially means drilling down to bedrock, coring into the Earth's mantle, and resisting that in a very expensive way. So what we like to do is resist that tension force by applying load, by applying the weight of the building to resist itself. So now when I push on this side, you see the building does start to deform. There would be a tension here, except the weight of the building, represented by these chalk blocks, is weighting it down and providing that couple. Next we'll look at see what happens when we add the outrigger system to the building.